Now let's talk about transformation orientation. Transformation orientation refers to how the axes of your object gizmos will be aligned. So to discuss the transformation orientation, let's activate our move gizmo. By default, the transformation orientation is in global orientation. So global orientation simply means that the transformation axes are aligned to the world's axis or the world space. And that's evident because if you take a look at the axes, you'll notice that the y-axis is in line to the y-axis of the grid, which is the world's axis. Same to the x-axis, you'll find that it's in line with the grid's x-axis, and likewise for the y-axis. So the next transformation orientation is the local orientation. So selecting local, at first you'll notice that it's similar to the global orientation. But if I rotate my cube a little bit, you'll notice that now the local orientation changes. This is because the local orientation aligns the transformation axis to the selected object's local space. Let's now do a practical example on how you can use the local orientation. So add a cylinder to your scene. So after adding the cylinder, you can move it to a position where you can view it more clearly. Switch back to global orientation. So while in global orientation, I want us to perform a rotation on this cylinder around the z-axis. Select the cylinder, press R, and rotate it around the z-axis. So I want you to see how this rotation occurs without affecting the top or the bottom surfaces of the cylinder. If I was to rotate the cylinder around the x-axis slightly, and then now to perform the same spin or the rotation that I did initially, it's gonna be impossible to do it, no matter which axis I use. Even if I move to trackball rotation, it's still not going to work. To perform the rotation that I performed initially without affecting the location of the top and bottom faces of the cylinder, I can do so by switching to local axis. Now I can now perform the rotation or the spin perfectly without affecting the top and bottom faces. Another thing to note is how to switch between local and global orientation using shortkeys. You first press the key for the transformation that you want. If it's moving, you press G to grab, then the axis that you want to perform your transformation along. So pressing that letter again will switch to global if you are in local orientation, and if you are in global orientation, now let's say we are scaling our object around the z-axis. First, it's gonna scale around the z-axis of the global orientation. Pressing Z again will switch the scale to the local orientation. So pressing a letter twice switches between local and global orientation. When you're in global, it's going to switch to local, and if you're in local, it's going to switch to global. Next is the normal orientation. In object mode, the normal orientation is quite similar to the local orientation. The difference now comes while you are in edit mode. So first, let's know what a normal is. So a normal is a vector that's perpendicular to the components of a mesh. So that's a line that's perpendicular to either a face, an edge, or a vertex. And to see the normals, you can enable them when you come to this overlays menu, and under normals, check on display normals for the faces and then display normal for the vertices. Now you'll notice that there are some lines on either the vertices or the faces of our cylinder. So these lines are the so-called normals. Now if I activate my move gizmo and select, let's say, a vertex, you'll notice that the z-axis will align itself to the normal of the selected component. If I select a face, the z-axis of the gizmo will be aligned to the normal of the selected face. Same thing with an edge. If I select an edge, the z-axis of the gizmo will be aligned to the normal of the edge. If you select multiple components, the normal will be aligned to the average normal of all the selected components. And normals are very important when you want to perform transformations along the normal. So let's switch back to object mode and discuss the next orientation, which is the gimbal orientation. So the gimbal orientation is more advanced for beginners, but let me just use simple words to explain it. So some instances, there are some rotation modes which can be accessed from this menu by pressing N. This menu will pop up if you press N, and then there's these rotation modes. So the gimbal orientation is useful for these rotation modes. As you change on these rotation modes, you find that you'll be in different rotation modes. And now what gimbal rotation does is that in these different Euler rotation modes, you can now rotate the axis of the Euler of the rotation mode and lock a particular axis which is known as the gimbal lock. So if I was to grab this object, for example, if I was to rotate this object, you'll notice that sometimes the angles between the axes are not always going to be affected in a way, because by default the angles between the axes is supposed to be 90 degrees. But in gimbal rotation, these might change depending on whichever Euler system you are in. For example, if I change to a different Euler system and try to rotate my object, you'll find that the axes of the angle between the axes are not always going to be 90. So as you see, if I switch to top orthographic, look at the angles, not 90. And that's where the gimbal rotation comes in, because it's going to align itself with the current rotation mode that's selected. So that's for the gimbal. The view orientation will always align itself with the view of the window, with the Y axis facing up the view and the X axis pointing the side of your view. So while you're in the view orientation, you cannot be able to see the Z-axis. This is because it's perpendicular to your view. That's because it's perpendicular to your view. And the view orientation is quite handy when you want to place objects on the camera. Next is the crosser orientation. So the crosser orientation, what it does, it just makes the transformation axis aligned to the axes of the 3D crosser. And you can change that under view. You come to the 3D crosser, and if you change the rotation of the 3D crosser, you'll notice that the axis also changes depending on how you rotate your 3D crosser. This one is very handy when you want to come up with a specific angle to perform your transformations. Next, we have parent. And before I talk about the parent orientation, you need to know what parenting in Blender means. Just like in real life, where you have a parent and a child, also the same thing can happen in Blender. If I select an object and come to the properties panel and under relations, click on parents, and now select an object that you want to be the parent of the cylinder. So I've selected cube. So the cube is the parent of this cylinder, and the cylinder is now the child. The cube being the parent, when I perform transformations on the cube, the same transformations that I perform on the cube will be performed on the cylinder. But if I perform transformations on the cylinder, they are not going to affect the cube in any way. So in short, the cube is the parent of the cylinder. So anything that happens to the cube will happen to the cylinder, but anything that's going to happen on the cylinder will not happen on the cube. So that's what parenting is. Okay, now that you know what parenting is, setting the orientation to parent will make the transformation axis in line with the local axis of the parent object. So in our scene, the parent orientation of the cylinder is going to be the same as the local orientation of the cube. Finally, you can create your own custom orientation. To do so, you need to select an object. So you can select any object present in your scene, or you can add a new object. So let's add a new object and create a custom orientation from it. So Shift A to open up the add menu. So let's add a cylinder. So grab this cylinder and place it to a position where you can view it clearly. So I can use the camera, the cube, the light, or the cylinder to create a custom orientation. So I prefer using the cube. So I'll select the cube. Change the local orientation of the cube by rotating it to your desired orientation. So the orientation of the cube is the one now that you'll use to create the custom. So the custom orientation will match the orientation of the cube. After you've reached your desired orientation, come back to the transformation orientation drop down menu and click on this plus icon. And now you can rename your transformation or orientation as you wish. So let's call it custom. And now click anywhere outside to confirm. Now we'll have a new custom orientation, which will be the same as the local orientation of this cube. So if I select on the cylinder, you can see that our custom orientation, that how it looks like, same with the camera and the light. So that's all about transformation orientations. Next, we shall learn about the pivot point, snapping, and proportional editing. So stay tuned for the next lecture.